Good morning. I am Dr. Mohammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. So today I want to discuss about network programming and management subject, in which the topics are address conversion functions, elementary top sockets, socket system calls. First, address conversion functions. What is meaning of the address conversion function? That means here, this address conversion function which convert the address from one form to another form. That is IP address to string the form or string form to IP address. IP address given to a socket application in a character format. It is also common for socket applications to need to display the IP address in a string format. The following are the functions work for the IPv4 and IPv6 address. That is inet underscore N2P. Convert a binary IP address, either IPv4 or IPv6, into string form. Inet underscore P2N. That means here converting an IP address in a string format to binary format. The function inet underscore N2A and inet underscore ADDR are still available, but they cannot be used for IP addresses. The address conversion function, some of the address conversion, the functions are function inet underscore P2N, inet underscore N2P. That means here which is converting the inet underscore P2N, which is the converting from IP address to the string, and inet underscore N2P, which is converting from the string to the IP address, reverse. That means here we are converting from one address to the another address, IP address to the string format or string format to the IP address. For example, here the IP address is 162.1.0.1. So which is converted by using inet P2N the function. It can be converted it as A dot B dot C dot D. That is a string format. Now we are converting this IP address numerical format. IP address is numerical format. From that the numerical format to, so which is the converted into the string the format. Here is Unix assembler callable services, so which is not applicable. For this one here, this is the conversion, so P2N or N2P or internet P2N or internet N2P, so which is not the applicable for the Unix assembler callable services. And take the C using languages environment. For this environment, now the conversion is applicable. That is inet underscore P2N the conversion or inet N2P the conversion is applicable. And capital P2N and N2P, so these are the conversion is not applicable to C environment. And if you take these IP CICS sockets, IP CICS socket, so it is also applicable. These are the conversion is the applicable. That is customer information control system. Customer information control system for this the IP address that is applicable for convertibility. REXS, restructured extended executor. So it is not applicable for this one. Socket extended. socket extended macro or call. So for this one, the conversion, internet conversion, INET P2N, INET N2P. So the conversion is not applicable for these two functions. And P2N for these socket extended macro or calls P2N, N2P. The conversion is applicable for socket extension. Next, elementary TCP sockets. Elementary TCP sockets are socket the functions, connect functions, bind functions, listen function, accept function, for and access the functions, and concurrent server, close functions, get sock name and get peer name functions are complicated other terms. So these are all the elementary TCP sockets. TCP, three-way handshake the process. Here, so this is a pictorial diagram representation for connection establishment using the three-way handshake the process. In this, the three-way handshake the process, now we can establish the connection and communication between the client and the server. Here is the server, first server now sending the SYN signal, synchronous the signals to the client sending the synchronous signals to the server. The server which is receives, that is a sequence number which by along with the sequence number which is sending the synchronous signals. And server here after receiving this synchronous signal and which is sending the synchronous responded with acknowledgement. If it is responded with acknowledgement and which sends the acknowledgement, receives the acknowledgement. Once it is server receives the acknowledgement, the three-way handshaking, the connection is established. Three-way handshaking connection is established. Three-way handshaking process. So first the client, what it is doing, in the first step, the client wants to establish a connection with a server. So it sends a segment with a synchronized sequence number which informs the server that the client is likely to start the communication and what sequence number is start segmenting with. So after sending the synchronous the sequence number, once the server is received this synchronized sequence number, immediately which is the server responded with the acknowledgement along with the sequence number. Step 2, server respond to the client request with acknowledge along with sequence. Signal bits set. Acknowledgement signifies the response of the segment. It receives and synchronize the signifies with what sequence number it is likely to start the segments with. Step 3 here in the final part, the client acknowledges the responses of the server and both establish a reliable connection with which they will start the actual data transfer. Here once the server receives the acknowledgement here, once the server receives the acknowledgement from the client which start the data transmission. After completing the data transmission, now we can disconnect those data transmission services. So here this is the representation of the TCP header. The three-way handshaking the process is the defined a set of steps that place in the TCP for creating a secure and reliable communication link between server and client. After completion of the the communication between the server and client, and it is terminated, it is closed. Actually, TCP uses transmission control protocol uses in a three-way handshaking process to establish a connection between two devices before transmitting the data. After the establishment of the connection, the data transfers take place between the devices, after which the connection needs to be terminated, which is also done by using the three-way handshaking process. So this is a representation of a TCP IP header. So in this, the TCP IP header, the elements are checksum, urgent the pointer, window, acknowledgement number, sequence number, source port, destination the port, length, and reserved checksum. So these are all the elements can be included in a TCP header. Here the elements in a TCP header are first sequence number. The sequence number is a random 32-bit number. So in the range of 0 to 2 to the power of 32 minus 1. This number which is assigned to the first bit of the data. Generally, a sequence number is used only once in connection is established. For other data transmissions in the same connection, some other random sequence numbers can be used. Next, acknowledgement number. So acknowledgement number, it is the next sequence number, that is acknowledgement sending device expect from the sender. It is generally a greater than the sequence number received from the sender. Window size. Here the window size is the buffer size. It is the capacity up to which data can be received in the buffer. And maximum segment size. Maximum segment size, it is a maximum acceptable size of each data segment by the connected device. Above this size, the device will not be able to receive the data segments. This is about the maximum size of segment. And synchronous flag. Synchronous stands for the synchronization. It can be described as a request for establishing a connection. If synchronous is 1, it means that the device want to establish secure connection, else not. So this is a synchronous flag. Acknowledgement flag. Next element is acknowledgement flag. The acknowledgement ACK stands for the acknowledgement. It can be described as the response of the synchronous. If acknowledgement is 1, the device has received the synchronous message and acknowledgement, else not. Fine flag. Fine stands for the finished. After the data transmission has been completed between the client and the server, the device have to transmit the connection using the final flag. That means here that is a finished flag. If FIN is 1, FIN is 1, fine flag. Fine stands for finished. After the data transmission has been completed, the device have to transmit the connection using the finished flag. If FIN is 1, the device wants to terminate the connection. Otherwise, which won't terminate the connection between client and server. Terminating the connection. Here, this is a pictorial representation of the connection termination using the three-way handshake the process. The client here which send the signal FIN, finished signal to server. The server here, once if it is receive the FIN signal, that is a finished the signal from the client, immediately which is sending the acknowledgement along with the FIN, finishing, that means terminating the connection. Immediately here which is sending the acknowledgement. Once if it is send the acknowledgement to the server, here adding the bit, that means acknowledgement. Now it is server sending the acknowledgement with along with fin, that is y is sending, but the client immediately which adding the +1, that is as a acknowledgement which is adding as a +1, that is acknowledgement is equals to y +1, so which is sending to the server. Once if it is the server is received acknowledgement y +1, immediately which terminate the connection. Here is FIN is 1. The device wants to terminate the connection. If it is not 1, if it is not 1 means here it is won't disconnect the service, the communication the service between the client and server, isn't it? So this is a three-way handshaking for terminating the connection from client and server. And terminating the connection here, now the steps are the client send the FIN to the server when the client wants to terminate the connection. It sets the FIN flag as a 1 for termination and sends the message to the server with a random sequence number. Here the acknowledge ACK is set to 0. The server replies with a FIN and the acknowledgement to the client. After receiving the client termination request, the server sends the acknowledgement to the client by setting the acknowledgement flag to 1. The acknowledgement number of the ACK is 1 more than the received sequence numbers. The client sends the acknowledgement to the server after receiving the FIN from the server. The client set the acknowledgement flag to 1 and send it with a acknowledgement number 1 greater than the server FIN, the sequence number, to the client. Here the FIN flag is kept 0 after the completion of the step. The connection is now terminated from the server to client side also. Like this, now we can terminate the communication between server and client by using handshaking 3, here by using the three-way handshaking process. Now we can establish the communication between client and server and terminating the service between client and server by using three-way handshaking process. Here is socket system calls. So what is a socket system calls? Elementary socket system calls. Socket. To do the network input output, the transactions, the first thing is a process must be do. So is to call the socket system calls, specifying the type of the communication the protocol. What type of the communication the protocol now we are doing, we are establishing between the client and server. It is the communication the protocol is the desired in a socket. The header files for this now we are using hash include sys.h type.h, include sys.h or socket.h, int socket, int family, int type, int the protocol, and the family is 1. Here AF underscore Unix, that is Unix internal protocols, and AF underscore INET, so that is a internet the protocol, AF underscore NS, so that is a Xerox NS protocol, and the AF prefix the stands for the address the family in the first the project. We are going to use the AF INET the family in a socket system calls. Here, the socket type is one of the following, that is a stream socket. Now we can say it as sock stream. Datagram socket, we can say it as a sock dgram. Raw socket, we can say it as a sock underscore raw. Sequenced the packet sockets, that is a sock underscore SEQ packets. Reliable delivery message sockets, that is sock RDM. RDM means reliable delivery message sockets not implemented yet. So the protocol arguments to the socket system call is typically set to 0 for most user applications. Socket system calls. A valid the combinations are here. The family for socket system call is AF address the family underscore INET, AF underscore INET. So the type is, it is a sock underscore dgram, that is a datagram type. Protocol is proto underscore UDP protocol. Now we can use UDP protocol. Once this family is using for system call, socket system call, now we can use the UDP, the protocol can be used. This is a UDP actual, the protocol is UDP, the protocol. By using UDP, the protocol, now effectively establishing the communication between client and server. Next, AF underscore INET, the family. Now here is the type is sock underscore the stream. The protocol is a TCP. That means protocol underscore the TCP. Here the actual protocol is TCP for that. And AF underscore INET. Here the type is sock underscore raw. And the protocol is proto underscore ICMP protocol. Now we can use the ICMP the protocol for transmitting data from client to server. The actual protocol is a ICMP protocol can be used. AF underscore INET the family. Here is the type is sock underscore raw. And the protocol is IP protocol underscore raw. Raw protocol. Actually here the protocol is a raw the protocol now we can use for establishing the communication from client to server. These are the protocols. By using these the protocols now effectively we can establish the communication between client and server. And bind system call. Bind system call assigns a name to a unnamed socket. Suppose if you are using any unnamed socket in a communication, client server communication, any other communication, now these are the bind system call which assign the name to the unnamed socket, which is giving the name. So here the header, this is the code for giving the other name, hash include system.h, sys.h header file or types.h header files. These are the directives now we can use. Hash include system.h or socket.h. Now this directive we can use for naming the socket name. For naming the socket. Int bind, the code is int bind int sock fd file descriptor struct sock addr pointer type, that is my address int addr length. By using this code, Python code here, now we can renaming the socket. Whatever the sockets are unnamed, we can rename the sockets. The first argument is the socket descriptor, which is returned from the socket system calls. The second argument is a pointer. to a protocol specific address. And the third argument is size of the address. This is about the bind system calls. There are three uses of the bind system the calls. The first one is a server register their well-known address with the system. It tells the system, this is my address, and any message received for this address ought to be given to me. Both the connection-oriented and connection-less servers need to do before accepting the client request. A client can be registered a specific address for itself. So these are all the uses. And third is a connection client needs to assure that the system assigned some unique address. That is, so that the other end, that is a server, has a valid return address to the responding to client. This corresponds to the making certain and envelopes has a valid return address. If we expect to get a reply from the person, we send the letters from the client and servers. Here, connect system call, socket system call. So this is a connect system call. Now, what we are doing in which one? A client process connecting a socket descriptor following the socket system call to establishing the connection with a server. For that now we can use the code. This is the code, Python code. Hash include now we can use sys type dot h header file, hash include sys socket dot header file. Now int the connection int socket file the descriptor struct sock addr star pointer type serve addr int address length addr length. So by using this the code now we can establish the connection between client and server. The socket FD, that is sock FD, is a socket descriptor that was returned by the socket system call. The second and third arguments are a pointer to a socket address and its size as described earlier. Here is connect. For most connection oriented protocols, that is a TCP, for example, now the connect system calls which results the actual establishment of a connection between the local systems and the foreign systems. That means here the connect system call does not return until the connection is established. Once if it is established the connection system call which is the returns. Otherwise here which is returns the error. If the connection is not if it is not established, which returns the error. So error is returns to the process. The client does not have to bind a local address before calling the connect. The connection typically causes these are the four elements of the association file tuples to be assigned. That is a local ADDR, local process, foreign ADDR, foreign the process. In all the connection oriented the clients, now we will assign the local address. This is about the connector system calls. Listen system calls. These system calls is used by a connection oriented servers to indicate that it is willing to receive the connection from server or from the client. Here is listening first. If the client send the request, listening request, now server what it is doing now which is listening. Hash include sys.h type.h. Hash include sys.h socket.h. Int listen. Int sock fd into backlog. So by using these the code, the client, the server is listen the client request. Once if it is listen the client request, immediately binding. After binding here, accept the this request. Whatever the request sent by the client, so that can be accepted. If it is accepted here, the connection can be established. Once the connection is established between the client and server, immediately data transmissions can be placed between client and server. So it is usually executed after both the sockets and bind system calls and immediately before the accept the system calls. So the backlog, the argument specify how many connections requested can be queued by the system while it is waiting for the server to execute the accept system calls. And this argument is usually specified as a FIO. The maximum value currently can be allowed. FIO can be allowed here because why? Because here now we are using the FIO tuples. That is the local ADDR, local other process, the foreign ADDR and foreign other process. So that's why here now, here the FIO specified as a FIO, the maximum value currently allowed as a FIO in a listen system call. And here is accept. Once the accept is, the server is accepted, the connection immediately, the data transmissions can be take place from client and server. After a connection oriented, the server executes the listen system calls described here. The actual the connection from the client process is waited by having the server execute the accept system calls. Now client is waiting until the system is accepting the client request. System this client the accept request. Once if it is accepted, the server is accepted, immediately establish the connection and sending the data. That is, here the code for this one here, the accepting, the code is int accept int socket fd struct socket addr star peer int star addr length. This accept take place the first connection request on the queue and creates the another socket with the same other properties as a SOCO FD, that is a socket file descriptors. If there are the connection request is pending, this call blocks the caller until arrives. Here if it is not accepted, the server is not accepted, the client is waiting up to getting the accept request from the server. If once the accept request is received by the server, so immediately the client is start the process. That means here the peer and address arguments are used to returning the address of the connected the peer the process, that is a client. The address length is called a value result. That means here the caller sets its value before the system calls, and the system call stored as a result in the variable. For the system calls, the caller sets the address length to the size of the socket ADDR structure, whose address is passed as a peer argument. These the process can be followed for accept the connection, the acceptancy by the server. If it is the server is once accept it is, now we can do the communication. Send to, receive from. So these are all the functions calls. By using these the function calls, now we can sending the information from client to server, and send to from for what for which the client you are sending, for which the server we are sending the request, and from which the server now we are receiving the request. Receive and receive from. Here is these are the system calls are similar to the standard read write system call. Both are similar to the read write, same as read write, but additional the arguments are required. Here is now we are using the some arguments. We are using the arguments here. Send to receive. The arguments now we are using. Here if you take send now we are using the sock fd char star pointer type buffer int bytes int flag. These arguments now we are using. Here also now we are using the say some arguments. Send to also we are using some arguments. Receive also we are using some arguments. Receive from also now we are using these arguments. By using these arguments now, effectively we can establish the communication from client to server or between the two devices now effectively establish the communication. The first three arguments that is sockfd buf buffer and n byte to the the system calls are similar to the first three arguments for read and write. The flags arguments can be safely set to 0, ignoring the details for it. Here, to the argument for the send to specifies the protocol, specifies the address of where the data is to be sent. Since this address is the protocol specifics, its length must be specified by the ADDR length. The receive from system call fill in the protocol specific address of who send the data into from, and the length of this address is also returned to the caller in the ADDR length. Here the final argument to send to is an integer value, while the final argument to receive from is a pointer to an integer value. So these are all the send to, receive and receive from. These the system calls can be performed effectively. Finally, the close the system call. Once the communication is completed between client and server, here now we can use the close system call. The normal Unix close system call is also now we can use to closing the socket. Int close int fd file descriptor. Whatever the file now you want to close here, now just give that file name. With this the file name here, now we are closing the particular so and so the communicating the file that can be disconnected. If the socket being closed is associated with the protocol that the promises reliably delivery, that is TCP and SPP, the system must assure that the data within the kernel that still has to be transmitted or acknowledged is sent. Normally, the system returns from the close immediately, but the kernel still tries to send any data already queued. These are all the system other calls. By using these all other system calls now, we can effectively establish the other communication. For effective establishment now, we have to utilize these other system call in a network other programming.
Like, share and subscribe. Hit the bell icon for more updates.